think everybody is almost here. Yeah, hello everyone. Welcome to today's interactive AMA session. I am David Jiao, CEO of Privasea, and also your host today. And together with the top FH players today, as a guest here, Zama from Fhenix lnco. And I would like to explore in the potential FHE use cases in crypto and Web3. And also, after the MA, we will also give our POH DApp referral code today after the Q&A session from the audience. Okay, I think everybody's ready. Let's start. How about let's do a roundtable introduction first. Ren, do you want to start?
Sure. Hey, everyone. Nice to see you all here. My name is Rand. I'm the CEO at Zama. My background is actually in AI. I did a PhD 20 years ago. Then after that, I was running a confidential machine learning company that got acquired. Working on building Zama, creating homomorphic encryption technologies.
Perfect. Thank you, Ren. Welcome. Remi, do you want to continue?
Yeah, hi everyone. So I'm Remi, founder of lnco. I've been in the crypto space since 2017. Previously worked as a software engineer at Google and Microsoft, and also as a crypto VC. And then previously was the founding member of a DeFi protocol on Polkadot called Parallel Finance.
Awesome. And Guy Zaki from Fhenix.
Thanks, David, and a pleasure to be here. Actually, most of my career spent at Intel, leading ecosystem development for Intel SGX, a trusted execution environment that you can run code in a secure way. Was always amazed about the fact that everything in the blockchain is transparent, and was looking to build a solution around that. Recently was a director at Intel for fully morphic encryption. Intel's building a ASIC for FHE as part of a DARPA initiative. And through that role, scanned the market, met everybody, and figured that FHE is really the end game for lack of data confidentiality in the blockchain space. We started Fhenix in 2023 as an L2 on top of Ethereum.
Awesome. Thank you so much, Guy. Okay, let's start. I think I'm quite excited, actually, to invite all of you guys from the FHE domain to talk about stories in the Web3. We can start with the first one. So as a deep tech leaders, and why you guys think FHE could be the next narrative in the Web3, and from the perspective of solving industry pain points, what innovations does FHE bring into this area, and what opportunities are there from your as participants' perspective? Maybe we can start with Rand again.
Sure. I can give you a bit of the history of how I've experienced FHE. I discovered FHE back in 2015 when I was working on confidential machine learning back then. But FHE didn't really work. It was extremely slow, and you could barely do anything with it. Certainly not complicated machine learning stuff. So it was this good idea on paper that didn't really work in practice. When in 2020 we started Zama with Pascal Payet, my co-founder, who's one of the inventors of homomorphic encryption, we thought that we could actually make it work for the first time. And so there was like three main problems to solve. The first one was making it faster, of course. The second one was making it usable for complex application like blockchain smart contracts, databases, or machine learning. And the third one was making it easy to use for a developer who wants to build a confidential application. So today, where we are with Zama and our technology called TFHE, is that we've made it super simple to use. So you don't need to know anything about cryptography to start building confidential applications, whether that's machine learning or blockchain. We have extended the capabilities of FHE to go beyond simple additions and multiplications into any kind of computation. In fact, our technology, TFHE, is the only one that guarantees that the result of the FHE computation matches exactly what you would get if the data was not encrypted. There is no approximation or anything like that. And finally, in terms of speed, we've improved the performance of FHE on CPU by 20x already, and we are on track to be at 100x in the next 12 months. But the big kind of enabler and breakthrough will come in the next couple of years with dedicated hardware accelerators, ASICs for FHE, where we will be able to reach 1000x or even 10,000x speedups. And so at that time, really, anything becomes possible. There's no more limitation in terms of what you could do. So yeah, the bottom line is that from a purely mathematical and developer experience perspective, FHE is a solved problem. It's just a question of making it faster and having as many people as possible use it now.
Awesome. Really glad to hear from Ran. From both usability side and the performance side. FHE definitely will be more and more popular, according to this machine learning and smart contract side, I think. Thank you so much for your answer. And how about the guy? What's your opinion on this part?
Look, there are several endeavors up until now trying to solve the privacy challenge around blockchain. Some were done using trusted execution environment. Others were done using zero knowledge. The reality is that neither TEs or ZK can really offer what the industry needs. TEs are, I would say, prone to side channel attacks. If there is an attack there, the fix is lengthy. And I would say in general, the crypto ecosystem just doesn't trust the hardware. And then on the other side, ZK are a great cryptography for scaling, but in its essence, it's a proving mechanism. It's not a computation mechanism. And when you want to start doing computation on data that is being received from multiple entities, ZK just doesn't work. It becomes very, very complex to try and implement a privacy mechanism using ZK. The industry has been waiting for FHE. I think Zama did a phenomenal job in bringing FHE to a point that it's usable and feasible for the blockchain space. And the opportunities are endless. I think what we've seen up until now, if you look at the history, is that in the crypto ecosystem, we had the challenge of scalability, and that was solved or partially solved or almost solved with rollups. There is a challenge on cost, but with modular design and data availability, we can also see the cost going down. The transparency challenge, which I think is a challenge, it's not a benefit, it's a blocker, has been out there for day one and isn't solved at this point. And we believe that FHE, Fhenix, lnco, Zama are the ones that are going to address that.
Awesome, Guy. I think your point on scalability and the usability side is quite incredible. And Remi, what's your opinion on this part?
Yeah, I agree with Guy that there has been a few different solutions in the past, and I think on-chain privacy will always come back in cycles and waves until this is a actual solved problem, which it isn't today. I think FHE is interesting as a narrative, also because it has very different properties compared to the other solutions. So for one, it's all cryptography based, so very aligned with kind of like the early cyberpunk kind of manifesto, using cryptography to solve privacy. It's also deterministic, which in the context of blockchain, you actually want to be able to verify the work in a very deterministic and replayable manner. So I think that property also makes FHE really stand out. And the third part is when you implement FHE into the blockchain space, it's actually happening all fully on chain instead of off chain. So I think that itself as a solution also really stands out. And then lastly, it's also post-quantum secure. I know recently we had this scare that, maybe lattice cryptography is no longer secure, but, ultimately actually today it is still relatively secure. And it turns out that paper had some minor, math errors. But yeah, I would say these properties really makes FHE stand out compared to existing solutions as a whole.
Thank you, Remi. I think we will bring this post-quantum computing topic later in the other questions later. But thank you so much. So we can start with the second one. Actually, is for Zama specifically. So, Ren, what's Zama's position in the Web3 field? What's your corresponding strategy and plans to develop in the crypto space?
I've been in crypto in blockchain since 2013, actually. So I've seen quite a lot of the evolution of that space. And one thing that always struck me, of course, is that, everything is public. So the reason why we decided to start building homomorphic encryption for blockchain applications was to try and solve that problem. So Zama as a company is not a blockchain company. We don't operate the network. We don't do any of that. What we are is a cryptography company building homomorphic encryption technologies and solutions that allows other people to build blockchain protocols, and whether those things are L1s, L2s, L3s, rollups, app chains, that's really, the same thing. Because from the homomorphic encryption perspective, the way you compute on encrypted data doesn't depend on the way you run your blockchain itself. And that's what's really nice, right? It just natively plugs in to the different flavors that you want to build in that space. So really our goal is to provide the absolute best possible FHE technology out there so that the companies like, lnco and Fhenix, or you guys, right, at Privasea, can start building those use cases. Like we're never going to build those use cases ourselves. We're just not staffed to be a blockchain company, but we're really, really good at building cryptography and FHE technologies.
Awesome. I think your strategy seems like you become, for example, want to be like Microsoft in the Web3, become like operating system for common use cases in the end, or maybe
so
it's not
we wouldn't
the
even
comparison. But it's
we wouldn't even be that. I think if we do our job right, nobody knows we exist because people are going to know you, they're going to know lnco, they're going to know Fhenix, they're going to know the applications running on your protocols, but they don't have to know that Zama is a technology provider behind it. Zama is not a retail-facing company, contrary to an operating system where Microsoft, everybody knows Microsoft. So I think maybe the closest you can think of us in a way would be like Intel Inside for FHE,
Intel.
right?
Yeah.
So if you guys want to put it like we're working together and put a Zama sticker on your website, great, we would love that. But it's not necessarily always the case.
Perfect. Okay. Yeah, we can continue with other topics. Actually, is one related to previous speaks from Remi, something about the post-quantum computing topics. The question is like the more laws has been yet disproven, but with continuous integration of the encryption technology and the increase of the computation power, do you think this poses a threat to the field of encryption, and how does FHE face and understand this threat in general?
Yeah, I can start briefly on it.
Sure.
Look, I would say, first of all, putting aside for a minute the quantum compute topic, one of the key features that we see with FHE and the work that Zama is doing is, unlike ZK, which has been out there for many years, but up until now, I haven't seen ZK application outside of the blockchain space, like in a massive way. FHE is the potential of FHE is quite broad. I would say it's probably going to be utilized across the board, cloud service provider, federals, not just on blockchain. I would say blockchain is probably the first real ecosystem that would adopt FHE, but it would go broad and beyond that, which means significant investment in research, in hardware, and beyond that. Clearly, with that type of magnitude, it also draws attention. We chatted at the beginning about the paper that was released about 2 weeks ago that claimed that lattice cryptography in general is no longer quantum safe, and there was a post-quantum algorithm that enables solving the LWE problem, and that didn't hold. There were problems with that. It was actually quite a good activity. There was a lot of discussion in the research community, and you could feel that people are getting excited about, is it true? Is it not true? Is there a problem? And eventually, we know that it's not the case. I would actually love to see more of these type of papers that explore FHE, lattice cryptography, try to pick holes and have peer reviews done, because that just grows us whole as an ecosystem. It brings a lot more attention. It brings a lot more focus. Whether the compute, I would say that the Moore's law from our advantage is probably a good thing for performance improvement around FHE. Whether that would eventually translate to some kind of a quantum computer or quantum algorithm that breaks FHE, time will tell. But I think this is a problem for the future. At this point, most of our focus is just on getting hardware out there to improve performance of FHE.
Well, thank you, Guy. I think it makes tons of sense. Remi, do you want to continue?
Yeah, I guess to add on that, in my opinion, it will always be a race. And this is also similar to, with viruses and antiviruses, right? There'll be new viruses and better patches, right, with it. Same with deepfakes and anti-deepfakes in the future. It's not the first time that people claim that certain cryptographies can be broken. There will always be more of these, and then there will always be more fixes. I think this is just something that I think we should all accept, that this is going to be some kind of infinite game, where there's always kind of like two oppositions. One is trying to jailbreak or break a system, and the other one try to improve a system. And the reality is, quantum computers are also very still far away. So I think it's a good thing that this came out today. If it were to be true, that actually would give us some time to, figure out a different solution, if that's the actual case.
Yeah, awesome. Randy, do you want to amend some on this part?
No, I mean, I think Remi said it, right? The important thing is when you think about FHE in general, is that the security of FHE today is as hard as any cryptographic stuff can ever be. And that's what people need to realize. The more people try to attack FHE, the stronger FHE gets. And it's not new. I mean, so there was this, incorrect quantum attack. But even beyond that, every couple of months, someone publishes a new attack on FHE. It doesn't break it, but it gives you an idea of how you can modify it in order to make it even more secure. So I would say that like where we are today with FHE is in an even better position than when we were a few years ago. So that's really important to understand. Like, you cannot trust a cryptography system that hasn't been attacked for at least a number of years. So it's not like, ZK, where in the case of ZK, well, you provide a proof and then you move on, right? You're not trying to keep something confidential for a very long time. In the case of FHE, the data you're encrypting is going to have to remain private for 50 years, 100 years. So you cannot afford to take a risk and use something that hasn't been proven yet. That's something really important to distinguish. And so there's really only been 3 technologies in FHE that stood the test of time so far, and Zama's technology is one of them.
Awesome. I think, yeah, totally agree. I mean, FHE is like any other encryption technologies, it's always been evolving during the time, and it will be more and more secure in the long run. Yeah, great. And we can continue with the next one, which is actually a lot of audience are quite curious about how, including Fhenix, lnco, and Privasea here, why we are choosing Zama as the fundamental technologies partners, and what kind of benefits Zama can, as the tech provider here, bring to us. I can start on this one first, I think. Then Phenix and lnco, you guys can also add in your parts on this question too. So from privacy side, I think from Zama, we recently discussed like a few meetings on both technologies, and I mean, algorithm wise, application wise, we talked a few aspects on how we can cooperate together, especially Zama's TFHEIS library, which will be using in our networks to integrating the algorithm for the distributed computing resources and AI models to enhance privacy and security of our networks. And for integration side, I think we will also using Zama's both TFHE library and the concrete ML for hosting models and in decentralizedly. And also we will continuously doing stress testing, security audits on all the solutions we have. And we also talked with Zama about the global key model and on the KMS and some other features we probably want. It's kind of like we will propose to Zama to do it in the near future, and that is, I think, will enhance the security and bring up scalabilities here in a lot of applications in the short near future. I think because privacy we build in proof of human application, so we do want to integrate it FHE on bring FHE on biometrics use cases into mass adoption in the short run. So so performance wise, security wise, we will enhance a lot by the cooperation. So that is the benefits I can talk about from privacy side, because Zama has a lot of experience building the tools and also integrating with projects. That's from my side. Thank you. And Remi, do you want to continue with that as a layer one?
Yeah, sure. I think there are two very specific considerations here. Which one of them actually Ren mentioned earlier is that the TFHE scheme has been out there for a few years now, and people have been attacking it for a few years. So this actually makes us feel a lot safer to use this scheme specifically because if you were to use something that's completely novel, although it might seem better or faster on paper, you never know how safe this is until it's proven to be safe with the test of time, right? The second thing is, we actually spoke with a few other FHE providers and considered a few different schemes. Ultimately, if you want to build a blockchain that has a smart contract capability, you need to have something like TFHE, which allows you to do, a pretty wide range of operations, such as additions, subtraction, divisions, also comparisons. And this also has to be in infinite depth, meaning that, you don't have to know ahead of time how many FHE operations you need to do. And this is particularly important in the context of smart contracts because you want developers to write application logic, and this piece is very variable depending on the use case. So you actually want something that has infinite depth, and this is where programmable bootstrapping, the ability to quickly compute bootstraps and enable basically an unlimited amount of operations to be chained becomes really, really important.
Awesome. Guy, do you want to continue?
Yeah, of course. I think for those who may not know FHE to the depth of this conversation, we mentioned FHE as if it's one thing, but there are actually different schemes out there in the FHE space. Some schemes like CKKS and BGV are, I would say, broadly or considered being broadly usage for like machine learning type because there's a lot of parallelization. Other schemes like TFHE is a much better fit for general computation. And from our standpoint, it was clear that when we want to build a blockchain, we need to enable developers to have the right to write smart contracts. So TFHE is the scheme to go. Zama were the ones that were leading the modifications around TFHE and bringing it to the level that is required both from a performance standpoint, but I would say even more important from a usability standpoint. If we had to go and get developers to start learning FHE or become cryptographers, that just wouldn't cut it. And I think with the FHEVM that Zama offers, it makes perfect sense to utilize that. It enables us, and similarly with lnco, to be Solidity-based, so developers don't need to understand cryptography. They just use Solidity in the tools that they're using to write smart contracts. Make it very, very easy to utilize FHE in that respect. Second is, of course, on performance. Yes, there is still a long way to go, but the performance that we get today is definitely feasible for applications that we believe are right and require privacy as part of it. Overall, yes, there are other providers out there. I just think that many of them are probably very early or more research-driven. And I'm actually quite excited to see what the future will hold. But for now, I'd say Zama are doing a phenomenal job, Rand and the team. And we couldn't be at this point, I would say, without the progression around Zama.
Yeah. Yes, indeed. I mean, it definitely you make the point here. I mean, we also, I mean, as a FHE machine learning application company, we also consider CKKS, which is probably more machine learning friendly compared to TFHE. But if you look at other libraries, maturity right now, Zama is way more ahead of the other libraries. I think you get the point very strictly. Thank you so much.
Well, thanks, guys. I mean, I have to say, working with you all has been really incredible as well, because as a technology builder, right, if we don't understand the use cases in application, we don't actually know what to prioritize. And, the feedback we're getting back from real world use cases is so important. And it's not just usability, it's like even things like, okay, is it more important for us to make things 20% faster? Or, do we have to start focusing on making the ciphertext smaller? Like, there's so many practical considerations nobody has ever encountered because nobody actually put this in production. And so really, I mean, Zama alone, without you guys, wouldn't know what to focus on. So again, like, it's been really incredible. And I have to say to everyone listening, lnco, Fhenix, Privasea, the quality of the engineers you guys have is just completely out there. Like, it's insane. And it's been really amazing to work with you guys because it's just so easy to work together. Like, it's the collaboration is just like so fluid. I love it.
Awesome. Thank you, Ren. Thank you so much. Let's continue with the discussion. So this one is probably for Fhenix guy. We'd like to talk about your as the modular layer 2 and what's your taking on the revolution of development and promotion that FHE would bring to the current EVM ecosystem on your side. What's your thought about this part?
Yeah, so as I mentioned at the beginning, we are an L2 on top of Ethereum. when we started the journey, we actually started Fhenix as an L1. We always knew that our direction was to become an L2, but there were some technical challenges around fraud proofs and how do you do fraud proof mechanism on encrypted content. And then last year, we were able to make our breakthrough in that respect. We released the white paper in October and basically fully transitioned to an L2. The reason that we're excited about that is clearly, the being very closely with the Ethereum ecosystem makes a lot of sense. But more importantly, the reality is around FHE is that it's very compute bounded. So the more hardware you throw on FHE, the better performance you get. From our standpoint, focusing the computation on a sequencer and validators enables us the scalability that we're aiming into the future. So that's one thing, and that it very much aligns with our path as an L2, and longer term also providing it as a stack. In addition to that, we've also announced 3 weeks ago the partnership that we're leading with Eigenlayer about building a coprocessor. And the reason we're so excited about the coprocessor is that though we understand that there are going to be many developers who will build on top of Fhenix, there are other L2s that may just want to utilize FHE as a service. And the rollup architecture enables us to also offer a stateless rollup that other L2s would be able to just call upon when needed to get FHE computation. And that would be secured by Eigenlayer staking. So I think from our standpoint, the vision around FHE is an L2, and that's where we're aiming to. In terms of application and use cases, I think there are so many. We can always start with just the ones that I would say everybody are talking in regards to use cases that just cannot live without data confidentiality, and whether that's voting and on-chain gaming, which clearly you cannot do a voting mechanism if everything's out there in the clear. You cannot do on-chain gaming like casino gaming if everybody can see your hands. And use cases, of course, as privacy are leading on AI. That's part of like the roadmap, but I would say probably there is also going to be a lot more focus on applications like trading, MEV, DeFi, that would require data confidentiality as a built-in capability.
Awesome. Thank you, Guy. And also congratulations to the Eigenlayer restaking partnerships. And really excited. Very exciting to see the progress in the model layer 2 here you guys are building. And also another question, short question for you is like, I also heard you're also building on Arbitrum Orbit. Is that something you want to share here?
Yeah, so what we're doing is we're utilizing the Arbitrum stack as part of our design. So we are building it as an L2 and not as an L3. We're utilizing the Arbitrum rollup, and we're integrating FHE into that. One thing that I probably didn't mention that I should is the modular design actually makes a lot of sense for us. As probably folks on the call know, when you encrypt content with the homomorphic encryption, the ciphertext is quite big. If we had to store that on Ethereum, I would say the cost would be significantly high. With the introduction of modular design and data availability, Eigenlayer, Celestia, Veil, that just brings, I would say the stars align. The fact that we have that option now that enables us to store significant amount of ciphertext on data availability with reduced cost is really a perfect fit. So that's like another reason why a modular design is one of the reasons we picked Fhenix as an L2.
Well, it makes a lot of sense. Thank you. The next question is actually for lnco, Remi. As a FHE EVM layer 1, what's your take on from the application side? What kind of chain applications you guys are focusing on to promote as application level in your ecosystem? And what do you think? What kind of applications would most likely become mass adoption in the near future?
Yeah, that's a good question. So, first of all, lnco is a general purpose smart contract blockchain. And then, because of that, really the design space here is very broad. You could be building around gaming, gambling, DeFi, governance, payment, identity. It just, what you have today on Ethereum and Poly blockchains like Ethereum, Polygon, Avalanche, all these applications, you can spend a lot of time thinking, what if I can, hide some information? So this is where, I think I would say the design space is really, really broad. And it can be really impactful, across a couple of verticals that, in my opinion, I think will be super interesting to see develop. So one of them is actually gaming. If you think about it today, crypto games today are all built on transparent blockchains. This is fundamentally very limiting because the types of games that you're used to playing Web 2 oftentimes require some kind of hidden information in order to be fun, right? So, for example, if you want to build some kind of like bluffing game, like poker, it just wouldn't make sense to build this on a completely transparent blockchain like Ethereum, because everyone would know your cards. And so this is, where we think that gaming will be a major focus on, because there's just so many new design mechanics that we can enable that has to do with bluffing. You can spy on people, you can consume resources. And these are the actual game mechanics that makes the game fun in Web 2. So that's, I would say, one part that I'm particularly bullish on. The second part I would say is probably DeFi. I think DeFi, today, the ones that we have today are the ones that more or less make sense, given that we have perfect information, meaning that, everyone sees what's happening. But, what if you can hide some information? So this is where I think there could be novel DeFi primitives that just aren't feasible anywhere else, happening on lnco, but also, Fhenix and other FHE-based blockchains. And I think fundamentally, not enough people have really spent enough time designing and researching around the space. So, for us at lnco, we also do a lot of research internally. We also work with some other folks who, are experts in this field. And we're really excited to see, what kind of novel primitives can come out of this in the DeFi space. And it's really a greenfield opportunity that, for people to really push for the boundaries of novel primitives in an area that I think, we're only, starting. And if you think about how a lot of the financial products works today in Web 2, you actually need some kind of, private information in order to work. And also, yeah, lastly, I think a lot of the tooling like governance, identity, even just, simple payment, payroll will probably be game changing, I would say, in this space. And this is because, ultimately what we're trying to enable here is more of a Web 2 experience in Web 3. Let's take a simple example of payments, right? For those who live in the US, have used something called Venmo. When you use something like Venmo, your balance, and also when you transfer money to your friends and family, that amount is also hidden. And Venmo is not even a privacy app. It has nothing to do with privacy. Venmo is just a commonly accepted user experience that we all have in Web 2. So this is where, I think a lot of the Web 2 experiences can be brought into Web 3 through, FHE with this concept of private state that's computable. And so we're actually really particularly excited to see, what sorts of, experiences, novel experiences people can bring from Web 2 to Web 3, because now we have this capability to expand kind of like the scope of use cases.
Great. That makes a lot of sense, Remi. Thank you so much for your answers. And I think we will get to the last question. Actually, I saw a Twitter I think last week from Rand, and you were talking a little bit about why FHE wouldn't cause compliance problems, but it actually develops better on both on-chain and off-chain data. Can you speak a little bit more on this part, Rand? Can you continue with that?
Sure.
And yeah, everybody can take turns after
Of course.
Rand.
I think, it's important to distinguish between, hiding someone's identity and hiding the data that belongs to someone. If you take something like Tornado Cash, what it does is that it removes the linkability between the sender and the receiver of money. But the funds you're transferring through Tornado are still public on chain, right? You can see how many ETH are going in and how many ETH are going out. You just don't know who's sending money to whom, right? So this is a way to hide your identity, if you want. This is something that governments in general hate. They hate it because if they cannot trace back people, they don't know who to, knock on the door of and arrest, right? So this is kind of like Tor. If you're using Tor to access online content, you're basically accessing public content in an anonymous way, but the content is public. So Tor and Tornado Cash are the same thing. Governments hate that. FHE is very different because when you use FHE in a smart contract, the transaction itself is still traceable. You can still see that like Rand sent tokens to David. You just don't know how many tokens were sent and how many tokens Rand and David are owning. So we're not hiding the traceability and the identity of the people on chain. We're hiding the content of what is happening on chain. And so this is similar to something like, WhatsApp encryption or Signal. The messages are encrypted, but they're being sent on a public network. So, the telecom operator still knows that my numbers sent a message to your number. So this is the same thing as FHE. And that's perfectly fine because as long as you have traceability, you can always figure out, what exchange that person used or which miner, the money came from or whatever. So this is really important. The privacy implications and privacy model of FHE is completely different to the one that you have with, Tornado Cash and these type of mixers.
Yeah, it makes a lot of sense. The metadata and the real data hiding are different, I would say, especially
Exactly.
ID side. Yeah.
Like your identity is metadata. The data itself is, the balance or is the amount. And there is actually a famous quote from a former CIA director who said, all they need to arrest terrorists is metadata. Because if they see you're exchanging messages with someone during, a terrorist attack, then probably you're involved. That's all they need to know. They don't care about the message itself. So this is not preventing that, So that's why I'm saying like it's important really not to think of privacy as a one size fits all, but to really distinguish what you're trying to hide.
Yeah, I think that is the meaning of this today's AMA because a lot of people doesn't understand the compliance behind the FHE cryptographic technologies. They always think it will cause compliance issues, but in contrary, it's actually solve compliance issues. Well, Guy, do you want to continue?
Yeah, I think it's really a good topic to discuss because when you think about what's happening today, because there is really no built-in solution to address compliancy, the reality is that when a regulator needs information, it goes to the infrastructure provider and requests that infrastructure provider to share the data, to bring the keys, to enable them to get everything. The beauty around FHE is that it enables the application developers to introduce the maturity as part of the application itself. If you think about it, there is like an inherent conflict between the need for KYC and the need to do GDPR. One requires you to share information. The other one requires you to maintain privacy. And FHE really unlocks that by enabling to do both while still maintaining everything private. And introducing that kind of capabilities as part of the application enables application developers to build solutions that the regulator can reach out upon need, get the information. There is an audit mechanism, and it's all built in. And this is the level of maturity that's missing today from the crypto space, and that can be achieved by integrating FHE. So I totally agree with what the both of you said, that FHE is probably the solution for compliance and a really good vehicle for that, versus just saying, yeah, we don't have a solution, let's just keep everything out there in the clear.
Awesome. Remi, do you want add some more here?
Yeah, I would say, from a compliance perspective, definitely, I think money laundering, terrorism funding, mixes, these are definitely more sensitive topics. But the reality is, if you want to do money laundering and things like that, like, something like Tornado Cash that's ZK based, that already works, right? So I would actually even argue that a FHE based, type of system to do money laundering is actually worse than ZK here. So first of all, there's nothing new here, and second of all, I would say it's a worse system because of the kind of like the traceability nature that Ren mentioned earlier. Yeah, if I transfer you some confidential ERC20, it's just the amount that's being hidden, and you can see that person A has transferred money to person B, so it's actually a terrible tool to do money laundering. So the way I see this is, you have public blockchains where everything is transparent, and you have ZK-based payment systems where because things happen off-chain, you can recut the link between the sender recipient, which is very, very private, but then gets into all sorts of troubles. And then you have FHE, which I think is kind of like the sweet middle ground, that really provides you that type of like Venmo experience where there is traceability and just enough confidentiality to have some sort of acceptable UX that I think is necessary for mass adoption.
Awesome. Thank you, Remi. I think we still have a little bit of time today, and I would like to give this chance to the audience here who wants to ask questions to all the guests here. So anyone wants to? Oh, there's several ones. Hello, FHE Future. Good name.
Thank
Nice to meet
you.
you.
Nice to meet you. Thank you
Nice to
for
meet you.
having me on. I wanted to ask the panelists a similar question around this compliance issue. Seeing all of the trouble that Tornado Cash and other privacy protocols have found themselves in. How do we maintain the promise of privacy in a regulatory environment where, like has been mentioned by Guy and Rand, the governments hate individual privacy, and for proper functioning, it is restrictive from that perspective. And how does FHE ultimately unlock this? I think you guys just answered a little bit of that, but would love to just dig into that a little bit deeper.
I can start answering if you want. So first of all, let's keep in mind that none of the developers of end-to-end encrypted messaging apps went to jail, right? Mark Zuckerberg is not in jail, and WhatsApp has end-to-end encryption for a couple billion people. The Signal folks are not in jail, right? The Telegram people are not in jail. So if anything, governments don't seem to be wanting to go after the developer of end-to-end encryption because, as I mentioned, they don't care, right? They can still trace back who's been interacting with whom, and they can always knock on your door, and they can force you to reveal your messages on your phone if they know who you are. So that's a reason why traceability is so important to avoid the kind of issues that we're faced with Tornado Cash. So that's the first thing. I think, just historically, this hasn't been an issue, so there's no reason why it should be different here with FHE. The second thing that Guy was talking about is with FHE, you can build on-chain compliance at the smart contract level according to whatever regulation you want to follow as an application developer. So, for example, nothing prevents you from asking the user to upload their encrypted identity on-chain. So nobody looking at the data on-chain would know who the person is because their identity will be encrypted, their name, whatever, social security number. But as a smart contract, you could request that the user reveals his identity to specific people for compliance reasons. So let's imagine, for example, you're building a DeFi protocol and you want to make sure that your users are not from the US because maybe the US doesn't allow using DeFi, right? Something like that. In FHE on-chain, your DeFi contract could verify that your encrypted nationality is not USA. And so all that kind of stuff still guarantees complete privacy with regards to the data that's on chain, but you're still enforcing regulation from the perspective of the regulator. And I think that's something that's very unique to FHE because at the end of the day, you can compute on private data. So whether the data you're computing on is your encrypted identity or an encrypted ERC20 balance really makes no difference to the algorithms behind it.
Yeah, I think Randy make a lot of sense on this point, and also I want to add some more on this point because I didn't speak for last question actually. So as Privasea here, before we started this proof of human app, this D app, actually we got some requests from some of the traditional social media companies, for example TikTok. They've been contacting us about how can we verify our users the age, which is under 14 years old, if they got a lot of fines if they are not verified, but they also want to keep privacy on the users. I think FHE definitely can make sure users the ages can be verified in a secret manner. I think that's a good use case actually for a lot of applications want to keep the compliance in public. I think that's my question on this. So FHE can actually improve compliance in a lot of situations, I would say.
Just maybe to add one last thing about that, compliance doesn't mean surveillance. Let's be really clear about that. Compliance means you're applying the rules, you're applying a specific set of rules because your application needs to follow those rules in order to be legal. It doesn't mean that you have to give away all of the details of the information which you're applying those rules. And this is what FHE allows you to do. You can literally apply the rules without revealing the data that you use to apply the rules. And I think that for me is that's incredible because you're completely separating compliance from revealing data. So let's not think of compliance as an issue. Let's think of compliance as a way to bring on board everybody in the world that doesn't have a choice if they want to start using blockchain, but to be compliant, right? Think about how big finance would be, how big DeFi would be if it was compliant. Every single bank, every single financial institution would start using DeFi.
Fully agree. Compliance and privacy are not contradicted at all. All right. Anyone else wants to? Oh, there's one more here.
Yeah, I would agree with Rand that there's a difference between compliance and surveillance.
Yep.
I was actually just chatting with someone yesterday who doesn't even use ENS because of it, right? Because everything is so public. And this is the state of today with a lot of these soulbound NFTs that centralized entities can issue you, is that all your metadata are completely transparent. And this is quite inconvenient because what if I just want you to know one piece of information, not everything, right? So this is where with FHE, if you were to store some kind of identity information in an encrypted manner, all you have to do is expose specific insights that you want to reveal to specific applications. And I think this makes a lot of sense, not just for individuals, but also for companies. It just today we have a system where, because everything is completely transparent, it's actually even worse than Web 2, right? There's no way for you to hide any trade secrets. There's no way for you to hide that you have bought something, let's say 5 years ago, which actually people can actually use this against you, right? What if you have a different political beliefs or a support of something else on chain? So this is exactly the problem today, is that you actually want to enable some kind of confidentiality to prevent surveillance, but you also want to balance it out with compliance. And this is where back to Brent's point, as long as governments can catch the bad actors, that's ultimately what they care the most about. So having FHE as this sort of traceable layer that solves the surveillance problem but still compliant, I think it is really an interesting sweet spot and novel direction in the crypto space.
Yeah, fully agree. Okay, let's move to next question from Boden. Do you want to say something? Hello, Boden. Nice to meet you. I think you can open your mic and shoot for questions. Well, it seems you have a little bit problem with your speaker. And let's move on to the next one, I guess. Hello, Puda.
Hello.
Nice to meet you.
Hey, and thanks for having me on here. So I just wanted to touch on the money laundering aspect of FHE. So I'm not sure if you guys have heard of DOP, short for Data Ownership Protocol. And they do a similar thing where they encrypt the transaction amounts when transferring or making any contract interactions. Have you guys heard of DOP, Data Ownership Protocol, and I guess what are your thoughts on it?
Personally, I haven't heard about it before this, but anyone else wants to comment on this question? Remi, Guy.
I mean, as far as I can tell, it's a ZK-based solution. So the thing about ZK-based solution for transferring money is they're fine, but they're very limited to that specific use case, right? So you cannot have composability on the encrypted amount, for example, that you're trying to transfer with ZK. And that's really important, right? Because composability on chain is absolutely fundamental to the whole point of a blockchain. So the difference here with FHE is that you have composability on the encrypted state. So in the case of ZK, if you want to have composability, you need to actually do it on the plain text on the prover side. So the prover will need access to all the information, which is not really a good idea if you're trying to protect privacy in general. You don't have that issue with FHE. So that's coming back to the point of Guy earlier. ZK is a fundamental technology for scaling. But in terms of computing in a composable way on encrypted state, FHE is really the way to go.
I can probably add that the more projects that are dealing with privacy and data confidentiality makes our life easier, because the end goal here is, at least at this point, is not necessarily is like FHE better than ZK or TEs. We know that it has a lot of merits. It's about proving the market need for these type of use cases. And what DOPE are doing, what Aztec are doing, what Alio are doing, they're all coming from identifying a problem, a core challenge that the crypto ecosystem is facing, each trying to solve it in different ways. It all makes sense. We definitely believe, and I hope we did a good job in explaining, that for the long term, for the next 2 to 5 years, it needs to be a mix of cryptography. It's FHE plus MPC plus ZK to solve it. Trying to solve it just with ZK is probably not the right path in the long run.
And maybe just to add on that, we've spoken with a few institutions who have tried ZK pilots for payments, and none of them panned out. One of the concerns was also this aspect of not being able to trace. And so, FHE here really offers a very different type of solution here that has unique properties that are more traceable. And this is also where, I agree. I think there will be a few flavors of privacy payments, but ultimately, which cryptography will become the one that's commonly accepted, that PMF will become more and more clear over time. And I guess everyone on this panel, right, will probably agree that we're extremely bullish on FHE because of this traceability in nature that's very different from ZK.
Well, thank you, Peter, and all the guest answers. And actually, the one last question is actually from me to Ren. Since we privacy here more focused on machine learning, I think there's the one last question is about how do you think, how long do you think FHE on machine learning training side would be more practical? I mean, especially for large models.
Well, I wish I could give you an exact date. The sooner the better for Zama, right? Clearly. So we are working really hard on that. So today, you can train simple models already. Probably we can make fine-tuning work in a reasonable timeline. Training a large language model, I would say, is the most complex application ever built in the world. So, even worse than FHE. So, on the way to training like GPT-5 in FHE, you would be solving every single other use case around machine learning. And I think, there's a lot that can already be super beneficial. Not everything has to be an LLM. In fact, 90% of machine learning workloads are using very basic models that would work already today in FHE. So we're working towards that, but I would say that training LLMs is the end game for FHE. And when we reach that point, then the entire internet could become encrypted end-to-end because everything else would be easier to do.
Sure. Thank you. I was hoping this answer from your mouth. Thank you, Ren. All right. I think we can wrap up today. Thank you so much for all the guests and also the lovely audience today. And wish you good night. And thank you so much.
Thanks, David, for inviting us.
Thanks, David. Thanks, everyone. Good chatting,
Thanks,
guys.
everyone. Thank
Cheers.
you, David.
Thank you, Remi. Thank you, Guy. Bye.